Welcome to the Explainer. Okay, so have you ever just been blown away by how an AI can pull up the exact right image from a super vague description? Well, today you're going to meet the engines that make all of that magic possible. We're putting two absolute titans of AI search head-to-head, HNSW and IVF. Let's pull back the curtain and see how they really work.
You see, we've totally moved past simple keyword matching. It's not about that anymore. A modern AI doesn't just look for the word dog. It actually understands the concept of a dog. And that means it can find pictures of golden retrievers, even if you just searched for fluffy yellow canine. This kind of leap, well, it needs a whole new kind of technology.
And, that gets us to the core problem. Your traditional databases, they're fantastic with neat, orderly, structured data. But try to show them an image or some audio or the subtle meaning in a sentence, they just completely fall apart. So what's the solution? We convert all this messy, complex data into these numerical lists. We call them vector embeddings. Basically, we turn it into a language a computer can understand and compare.
Now, imagine searching through millions or even billions of these vectors one by one. I mean, it would take forever, right? That's where Approximate Nearest Neighbor, or ANN, search comes into play. And the key word here, believe me, is approximate. ANN doesn't promise the perfect result. It promises a good enough result, and it does it at lightning speed. It's a shortcut that makes the impossible possible.
So to make this high-speed ANN search a reality, we need a special kind of map for our data. We call it an index. And in the world of vector indexing, two main strategies have really risen to the top. Each one has its own philosophy, its own way of building the fastest, most efficient map for your data. And their names? HNSW and IVF.
All right, first up in the ring is HSNW. Yeah, the name is a total mouthful, but the idea behind it is actually pretty brilliant. The easiest way to think about HSNW is like a super efficient multi-level highway system for all your data vectors. It's all about creating smart shortcuts. So here's how that highway system actually works. HSNW builds this graph with multiple layers. When your search comes in, it hops on the top express lane. This lets it jump between really distant points to get into the right general neighborhood, super fast. Then it starts moving down through more and more detailed layers, kind of like taking the local roads, until it zeroes in on the absolute best matches. It's just an incredibly quick and precise way to get where you need to go.
Okay, our second contender, IVF, takes a completely different path. If HNSW is that complex highway system, I want you to think of IVF as more like a meticulously organized library. Where every single book has its perfect place on a shelf? It's all about partitioning.
So what IVF does is it starts by chopping up the entire dataset into a set number of clusters. Think of these like the different sections in that library, fiction, history, science. When you make a search, it first figures out, okay, which one or two sections are most likely to have the answer I need? And by completely ignoring the rest of the library and only searching in those few specific sections, it saves a massive, massive amount of work. So there we have it, the highway system versus the library. Two totally different strategies for finding the same thing. Now, let's put them side by side. Let's see how they really stack up when we look at the things that actually matter: accuracy, cost, and just sheer scalability.
In round one, we're talking about pure accuracy. And honestly, HNSW is the undisputed champion here. That complex graph structure means it's just way less likely to miss a relevant result. We're talking over 95% recall, which means it finds 95% of the actual best matches. Now, IVF can be really accurate too, but you have to tune it just right. You have to tell it exactly how many library sections to check. So it's always this trade-off between going faster or being more thorough. But all that amazing accuracy, it comes at a price. And in the memory round, IVF lands an absolute knockout punch. HSN's W web of connections takes up a huge amount of RAM. We're talking 3 to 5 times the size of the data itself. IVF, on the other hand, is so lean. It can be compressed like crazy, making it the clear winner for anyone working with a budget or limited resources. Okay, next up, what happens when your data is constantly changing? Well, HNSW really shines here. You can just add new vectors into its graph on the fly. No problem. It just works. IVF is a little more rigid. Yeah, adding new data is easy, but over time, its library sections get outdated. And that means you have to do a full and often really costly rebuild of the whole index just to keep the search quality high. And for our final round, scale. Because when you're dealing with billions of items, the entire game changes.
HNSW is like a sprinter. It's unbeatable, blazing fast, as long as everything fits into that high-speed RAM. But IVF is the marathon runner. Its efficient design is just far better suited for these gigantic datasets that have to live on slower disk storage. And that makes it the only practical choice for true web-scale applications. So let's just take a look at the final scorecard. As you can clearly see, there is no single best algorithm. It just doesn't exist. HNSW wins on accuracy and on flexibility, which is perfect for performance-critical jobs. But IVF absolutely dominates on cost, on scale, and on build speed, things that are crucial for truly massive systems. It's that classic engineering trade-off, right? Precision versus resources.
And that gets us to the most important point. This isn't about which one is better in a vacuum. It's about which one is the right champion for your specific fight. And the answer depends entirely on what your priorities are.
You should be leaning toward HNSW if accuracy is just non-negotiable. Think about things like those advanced AI chatbots. They have to pull the most precise info to give a good answer. So if your data is always changing and you've got the memory to spare, HNSW is going to be your workhorse.
On the other hand, you're definitely going to want to choose IVF if your biggest worry is your budget and your memory constraints. If you're building, say, a massive product recommendation engine with 1 billion items and that data is pretty stable, IVF's efficiency and its ability to scale are just completely unmatched.
But here's where the story gets really, really interesting. For years, the whole debate was HNSW or IVF. You had to pick a side. But what if you didn't have to choose? Well, the smartest engineers out there are now saying, why not just use both?
And this right here is the state of the art today. Modern vector databases are creating this powerful alliance between the two. They use IVF to make that first broad cut, to quickly find the right library sections, and then they unleash the power of HNSW to run an ultra-fast, super-accurate search inside those small sections. You get the best of both worlds, IVF's incredible scale and HNSW's incredible speed. This hybrid approach really is the gold standard right now. It's a brilliant solution to a really complex problem, but it also leaves us with one final question to chew on. In a field that moves this fast, combining the two best ideas of today is smart. But what completely new idea is going to define tomorrow? What comes next?